Hello and welcome everyone to my channel Code with Ease. So today, as part of the binary search series, we are back with another question which is called search in a rotated sorted array. So there's an integer array nums which is sorted in ascending order, and in this case the array is rotated at some unknown pivot index such that this is the order in which it is going to be. So it is firstly going to be in the increasing order, then there's going to be the last element, that is the nums of n minus 1. So last element followed by the first element, and then from that onwards it is again going to be in an increasing order. We'll see the example in a while. So this is the array that we have, and if it is rotated, let's say at pivot index 3, and this is the array how it is going to become after rotation. So now if the array is rotated, our task is, given a target element, we have to find out which is the new index of the target element. In the original array that we have, that target element will have a certain index, but when we rotate that array, the index of the target element is going to change. So the task is, if the array is rotated, then what should be the new value of that index. So that is what it is told, that we have to return the index of the target if it is in nums, and if it is not found, then we have to return -1. And we need to write an algorithm which can be solved in order of log n. So as it is quite evident from the last line that we have to apply an efficient algorithm, and since it is searching, so we can use binary search. Okay, so let's walk through the example. So this is the array that we have, target is 0, so we can see that 0 is over here, which is at index number 4. But in the original array, if you think, since this is a rotated array, what is the original array? This is the original array. In the original array, the index of 0 is 0, but in this case, since the array is rotated, the index value has changed. In the next example, we can see the target is 3, but 3 is not even there in that element. So 3 is not even present in the array, hence the output is -1. So now let's try to see. So now let's see what should be the approach for solving this question. Okay, so now we'll discuss the approach for this question. So this is the original array that we have. So when we are saying rotation all the time, what do we exactly mean by rotation? So if this is the original array and if it is rotated one time, then what happens? It will be right rotation in this case. So it will be 7, the last element will come over here. It is going to be like this, circular, as if the elements are moving in a circular fashion. 7 will come over here, followed by 0, 1, 2, and all the other elements. Let's say it is rotated again. Now 6 will come at the front, so it will be 6, 7, 0, and rest of the elements. Again, if it is rotated, so then it will be 5, then 6, 7, then rest of the elements. So let's say this is the rotated array which is given to us, and in this we have to find our target element, which is, let's say, 2. Okay, so far so good. We are given an array and we have to search an element. We can directly apply binary search and find out the element. But what is the challenge over here? Why can't we directly apply binary search? The challenge over here is in this portion of the array. Remember when we talked about this, that the last element and the first element are going to be placed next to each other after rotation, after some number of rotations. So as a result of this, the array is not linearly sorted. When I say linearly sorted, I mean it is not as if all the elements are sorted in one single order only. Because if you notice, the last element and the first element, how is the order? It is like 7 is greater than 0. So it is like a descending part of the array. Whereas every other element sequence is in ascending order, like 0, 1, 2, 3, 4. It's in ascending order. 5, 6, 7. It is also in ascending order. So while the other halves of the array are sorted in ascending order, there is only 2 element which is going to be in descending order in case of a rotated array. So this is a challenge over here where we cannot directly apply binary search. We will eventually have to apply binary search only, but we will have to add more conditions to that. So we'll see that. So this is the challenge for this question. Okay, so now that we know, first of all, there will be 2 elements in which the order will be in descending. Okay, and there will be 2 halves of the array in which both the halves are going to be sorted in ascending order. This is what is given to us. This is what we can deduce. So now what we can do, see, if we are given a target element, what are the possibilities? So the first possibility is, okay, if we talk in terms of binary search, as we are anyway going to apply that, so we'll have these 2 pointers, we'll have the low and the high pointers. If you guys are new to binary search and know nothing about it, I would highly recommend to check out the playlist in the description, where from first video we have covered from scratch about the binary search, the dry run, the overview and everything, and then we are solving the questions one by one on binary search. So do check out the link in the description. So we have the low and the high pointer. What is low? Low is going to be usually the 0, the first element, and high is the last element. Okay. So on the basis of this, we calculate the mid. This is the initial structure of the algorithm. Okay. So the first possibility could be the target element that we are looking for is exactly equal to the mid. If that is so, we can return mid. Simple. No, nothing complex in this. Okay. What is the other possibility? Other possibility is the target can lie in either of the halves. When I say either of the halves, I mean it can either be in this portion of the array or it can be either in this portion of the array. Again, why are we dividing into two halves? Because of this condition where after a certain point, or if I talk in terms of the question, there is a pivot element. What is the pivot element in this case? The pivot element is going to be the point at which it is rotated. Okay, so now the target can either lie in this half or it can lie in this half. Now we have to figure out in which half of the array the target is in and then manipulate the pointers accordingly. Okay, so now I'll elaborate more on the second point. So let's say our mid is over here. Let's say it's at 0 and we are anyway searching for this element 2 and low is at the beginning, like low is at 5. Mid is 0, low is at 5 and we are searching for this element. So in all certainty, this half of the array, the element is not present. So what we have to check? We have to check first of all whether the low, means the element at the low index, is lesser than the element at the mid. So we'll check if this is lesser than equal to the element in the mid. Why are we doing this? This is basically a range check. When I say range check, I mean whether we are going to consider this half of the array or whether we are going to consider this half of the array. So let's say if this condition is true, means we are in this part of the array. So after this, we have to check whether this given target that we are searching for, whether this target lies in the above range or not. Means in the range of low to mid. 5 is the low, 0 is the mid. Whether my element, the target, is available over this range or not. How do we check this? We'll just simply do if 2 is greater than equal to 5 and less than equal to 0, something of that sort, which is in this case very clearly not. If our target was 6 or 7, then it would have been in this range. So since this check is going to be true but our target is not in this half of the array, where else do we search? We have to search in this part of the array, right? If we are searching in this part of the array, then we will be able to find whatever the target, wherever our target is. So how the pseudocode will look like? So first step is this, when the ARR of mid is equal to target, which I have already discussed. Next, what we told is if the ARR of low, means the element at low, if this is in this range, if like it is lesser than equal to mid, means we are in the first half of the array. So in that, we'll simply check if the target is also in that range or not, like from low to mid. Okay, I'm not writing the condition for that. So if it is there in that target, if that is true, so what we have to do is the high pointer, we have to pull it to mid minus 1. Means if low is here, mid is here, and let's say our target is 6. So in that case, high was anyway at the last. So we'll pull the high pointer to mid minus 1 because we need not search in this portion of the array. We need to search in this portion of the array. If we have to search in this portion of the array, the low, high and mid should be concerned about this portion of the array only and not in this. So that is why we are pulling the high to mid minus 1. Okay. This is the case in which the target is in this range. Or if it is not in this range, what we have to do? We have to do it in the other half. So if the target is not in the first half of the array, means if this condition is not true, then where do we have to search? We have to search in this of the array. So we'll just manipulate the low pointer to mid plus 1. Same as the concept of high equal to mid plus 1, means low was here and in this case like our target was 2. So if 2 is not present here, it's present here. So we will just pull the low towards the second half of the array, means mid plus 1. Okay, so this is all about this condition where low is less than equal to mid. Otherwise, what is going to happen? If this condition is going to be false at any given point in time, means let's say our mid is over here. Let's say our mid is over here. Mid is let's say at 3 and low is at 6. So will the condition be true? 6 is not less than mid, right? 6 is greater than 3. So if this condition is not going to be true, means we simply have to search in the other half. Okay. So if this condition is not true, then what we have to do is we have to start searching for the element in the second half of the array. So in that we will basically see whether the given target lies in the range of mid plus 1 to high, means the second half of the array, if it is going to lie in that range or not. If it is in that range, so if the target is in this range, mid plus 1 to high, what we have to do is we have to pull the low pointer. We will make low equal to mid plus 1. Else, otherwise I'm just writing it over here, else just the opposite, high equal to mid minus 1. Meaning, if this condition is false, like the 6 and 3 thing which we were searching for, we will try to search for the target in this half of the array. Let's say the target was 2 and we have searched in this. But what if the target was 7 or 5, whatever? So in that case, this condition would have been false because target is not in this range. The target, if the target is, let's say, 5. So then what we will do is we'll pull the high pointer to mid minus 1, means we'll try to search now in the first half of the array instead of searching in the second half of the array. Just the reverse of what we are doing in this portion. Okay. So in that way, it's just the game of like playing with the pointers. Where to pull which pointer, whether to pull the low pointer or whether to pull the high pointer with respect to the mid pointer, and then try to find out the element, the target element in that half of the array. That's it. So with that, now let's see what is the code implementation for this. Okay, so starting with the code changes, we'll define the low and the high pointers first. So what is the first condition we talked about? It is the traditional thing that we do, whether the mid itself is equal to the target. If that is true, we'll return the mid itself. Otherwise, we have to now do the other conditions. If nums of low is lesser than equal to nums of mid, then within this we have to check if target is in that range or not. So whether target is like greater than equal to nums of low and less than equal to nums of mid, means it is, if it is true, it is in that range, then we have to pull the high pointer to mid minus 1. Else the opposite, low equal to mid plus 1. The else block for the above if means this one. So in this we have to do this check again, but we are going to change the pointers. So we'll say if it is greater than mid plus 1, because the checking with mid we have already we would have done. So we'll do this, that if target is greater than equal to nums of mid and target is less than equal to nums of high. So if this is true, means the target is in the second half of the array. In that case, what we have to do is low equal to mid plus 1. We have to pull the low pointer ahead. And if this condition is not true, then we will do high equal to mid minus 1. So end of this else block. And finally, outside of this while loop, let's say this condition never was true. So in that case, something we have to return. What we have to return is minus 1, means the element was not present in the array itself. Okay, so with that, now let's run this. We'll submit. Okay, so yeah, that's all about this question, how to look for an element in a sorted and rotated array. It's a different type of an application of binary search with little bit more conditions in between. Hope you guys have enjoyed the session for today. Do let us know in the comments below if you guys have any questions or doubts, or you want to share any feedback on this video. If you have enjoyed the session so far, do hit the like button so that this can reach out to many more people. And if it does, it just gives us enough motivation to put out more such content. Also, if you are looking forward to more videos like this, please don't forget to subscribe to the channel and press the bell icon next to the subscribe button to never miss an update on our upcoming videos. Thank you so much for watching.